Good morning, my YouTube viewers. It is Crystal here. For those of you who watch my videos, you may know that I was recently in hospital. I had quinsy and then I had sepsis. So I was really very poorly. So for that reason, I want to thank all of my subscribers, everybody who subscribed to my channel. It really kept me going, just knowing that people were watching my videos and subscribing to my channel. But because I was so poorly, I didn't get a chance to do the May 22 Kaggle tabular competition until a few days after I got out of the hospital. And I wanted to wait to do a code review. And the reason why I wanted to wait and do a code review is because my voice was very poor. And so I didn't want to do a code review for that reason. But I've recovered a bit, so I decided to go ahead and do a code review on May 22 binary classification, Kaggle's tabular competition. And I've made it public, so anybody can look at the code, anybody can copy the code. One thing that really disappoints me about Kaggle is they make their data sets so large that you can't do much with them. And since this was such a large data set, what I did was I used Logistic Regression, because Logistic Regression is just a standard classifier. I think in the last month, I tried to use PyTorch, and PyTorch didn't do any better. It didn't do any better than the standard sklearn model linear regression that I was using. So what I do is every time Kaggle has a tabular competition, which is every month, I try to enter the tabular competition. And so basically, because the data set is so large, I didn't score very well, but I scored. So that's important that I scored. And I suppose there's a possibility that I could have scored better if I had put it on the GPU, but I didn't put it on GPU because it's hard to get on the GPU. You have to wait in line and stuff like that, and I'm in a really big hurry. So what we'll do is I'm letting you know this is what I scored when I entered the tabular competition was only 0.61304. And so basically, that's not a great score, but it did get me on the leaderboard. And the reason why I didn't score better is because the data sets were so large. But I'm giving you a lot of good techniques to use in your machine learning nevertheless. So this is your problem statement. The May edition of the 2022 Tabular Playground Series binary classification problem that includes a number of different feature interactions. This competition is an opportunity to explore various methods for identifying and exploiting these feature interactions. So the first thing that I did was I imported the libraries. The libraries that I used for this tabular competition question were NumPy, which performs mathematical operations and also creates NumPy arrays, Pandas, which creates and manipulates data frames, Matplotlib, which is visual graphics, and Seedborn, which is a higher level visual graphics. And also, I'm using sklearn, which you'll find later in the program, and sklearn is your machine learning library. I also imported OS, which goes into the operating system and retrieves the files that you need. So we imported OS and we went in and retrieved the files that we need. We had train, test, and sample submission. Then what I did was I read the files. I used Pandas to read the files, so I named them train, test, and submission. So you can see train is here, It's 900,000 rows by 33 columns, and it does have a target column at the very end. You can see test is 700,000 rows by 32 columns because test does not have a target column at the end. And this is submission. This is what Kaggle wants to see. So after we look at the submission, we're going to analyze the train. So we checked the info, and all of the features were numeric except for one float. And as we get into the program, I decided just to go ahead and delete that feature from the training model. And then we described it. This gives you your statistical functions. And then what we did was we analyzed the target. And you can see you had a target of 0 and 1. And there were slightly more zeros than ones. And now what we're going to do is we're going to define our target. Target equals train target. And so you can see we've defined our target. Now we're going to combine train and test to form a data frame called COMPI. So COMPI equals train dot drop target, axis equals 1 dot append test. COMBI equals COMBI drop ID and F27 axis equals 1 COMBI. So we dropped two columns. We dropped the ID column because ID column isn't necessary, and the reason why is because you've got an index, and the index is going to keep track of everything. And F27 was the only object column, so I just decided to drop it and not worry about it. And so you can see we've got only 30 columns now and 1,600,000 rows. So now we look at the heat map. You can look at the heat map and you can see that the vast majority of the features have a low correlation. Because what I wanted to do was I wanted to delete the features that had a high correlation just to make it easier for the model to train and make predictions. We print the correlation here. So this is the correlation between every feature. And so what we did was we decided to remove the columns that have a high correlation, but these columns all had a low correlation, so no columns were removed. And then I just kept it at 80%, so it's still 30 columns. Now what we have to do is we have to scale the data, and when you scale the data, what you do is that takes all the data and it converts it to a value between 0 and 1. And that's what the logistic regression model wanted to see, and wanted to see the data scaled. So COMBI equals COMBI minus COMBI min over COMBI max minus COMBI min. And then so all of the values are between 0 and 1. Now what we want to do is we want to define our x and our y variables. Our y variable is our target. Our x variable is COMPI up to the length of train. And our x test variable is COMPI from the length of train to the end. And now what we're going to do is we're going to split the data set up for training and validation using sklearn. And the validation set is going to be 10%. Now we select the model of logistic regression. And so this is we trained the model and we only had 61.49%, which isn't very good. But that was mainly because there were so many rows of data. Now we predict on the validation set, 61.36%. Still not very good. We produced a confusion matrix, so you can see that, you had a poor accuracy. And now what we wanted to do is we wanted to predict on the test set which we did. We predicted on the test set. And then we submitted our data. We prepared our data to be submitted to Kaggle. And that's it. And then so basically, that's it for this binary classification problem. I decided I was only going to do it once because I didn't get to work on it until I came back from the hospital. And then even when I came back from the hospital, I wasn't feeling very well the first few days. So it took me a couple of days to get this done. So this is your code review. That's what I personally did to try to get a really good accurate score. But that's one of my complaints about Kaggle is they're making their data sets so large that these data sets are actually crashing the system. And because it's crashing the system, you're not really able to do much with it. But I did what I could. So I'm going to go ahead and conclude this video. If you like my video, please like, subscribe, share. And I want to thank all of my subscribers for supporting me and subscribing to my channel and watching my videos. And thank you so much. And I look forward to making more videos for you in the future.